The periodic table is a tool that organizes all known elements by their properties. Each box on the table represents an element with its symbol, atomic number, and sometimes its atomic mass. This table allows scientists and students to see patterns in element properties and predict their behavior. The table is divided into rows and columns. Rows are called periods, and each period represents a new energy level for electrons. Example, period 2 means there are 2 energy levels or shells for an element. Columns, known as groups, contain elements with similar chemical properties and the same number of valence electrons or outermost shell electrons. For example, group 1 elements are metals and are very reactive with 1 valence electron or 1 outermost shell electron, while group 8 elements are noble gases, which are stable and unreactive with 8 valence electrons or 8 outermost shell electrons. We will continue our discussion on the periodic table, a fundamental tool in chemistry and physics. To start with, the periodic table is essentially a tabular arrangement of all known chemical elements. Each element is placed in order based on its atomic number, which refers to the number of protons in the nucleus. This order not only organizes the elements by their atomic structure, but also highlights recurring chemical properties. As mentioned in the previous slide, the rows in the table are called periods, and these go horizontally across. Meanwhile, the columns, which are vertical, are referred to as groups. Each group has unique characteristics. Groups 1 to 3 primarily contain metals, though there's an exception with hydrogen. Group 4 contains semi-metals. Groups 5 to 7 are home to non-metals. Finally, Group 8, also known as the noble gases, consists of elements that are chemically inert. For today's discussion, we focus specifically on the first 3 periods of the periodic table. This selection provides a foundational understanding of elements from different groups and their properties. Each element has an atomic number, which is the number of protons in its nucleus, and a mass number representing the sum of protons and neutrons. The atomic number is always smaller and is crucial for identifying the element, while the mass number gives us an idea of the atom's mass. With the atomic or proton and mass numbers, we can determine the number of protons, neutrons, and electrons in an atom. For example, germanium with an atomic number of 32 has 32 protons and 32 electrons, balancing the charges and making the atom neutral. In this exercise, you are to determine the number of protons, neutrons, and electrons in the atoms of the following elements. Note, the mass number can be rounded up or down to the next whole number, whereby carbon C has a mass number of 12, nitrogen N has a mass number of 14, and sodium Na has a mass number of 23. Pause the video while you determine the answers. Play the video when you are ready to check your answers. Here are the answers.